Hey everyone, it's Mrs. Hinckley. In this lesson, we are solving rational equations. So if you see a rational equation that looks like this in example 1, you can simply cross multiply the way that you would cross multiply if you were given a fraction equal to a fraction. To solve this equation, you would multiply a by d, set that equal to the product of b times c. So we're going to use that strategy to solve this example. So first I would take 3 times the quantity of 4x and set that equal to the product of 9 and the quantity x plus 1. From here, we just distribute, combine like terms, and solve for x. Divide both sides by 3, and the solution is -2. Okay, so just like with radical equations, we want to go ahead and check that this solution works. So plug -2 back into the original equation, substituting -2 in for the first expression, I get 3 over -2 plus 1 equals 9 over 4 times -2 plus 5. Simplify, we end up getting -3 equals -3. So this checks out. So x equals -2 is our solution. All right, in this next example, notice I don't just have a fraction equal to a fraction, so it's not just like a proportion like the first example, so we can't just cross multiply anything here. So notice we have a sum, so we can combine that by finding a common denominator first, or we can find a common denominator for all 3 of these expressions and multiply each side by that common denominator. So notice that the common denominator here, more specifically the least common denominator in this case, ends up being 4 times x. So if we multiply everything by 4x, we're going to basically get rid of that denominator. Okay, when we simplify this, we get 5 times 4x over x, which is 20x over x, and those x divided by x terms will cancel. And then we have 7 times 4x, which is 28x. 28x divided by 4 would just be 7x. On the right side, we have 4x times -9. So we have -36x divided by x would leave us with just -36. Now when we solve, we get x equals -8. You want to check that -8 works for the original equation. So go ahead and take -8 and substitute it back into the original. When we do this, we do get 9/8 equals 9/8, so it checks out and -8 is our solution. All right, in this next example, I have a typo. That should be 1 minus 8 over x minus 5 equals 3 over x. Okay, so let's get started on solving this rational equation. Notice that we cannot simply cross multiply here because it's not a proportion. So what we're going to do is find the least common denominator among these expressions and then multiply both sides by that common denominator so that we can basically eliminate the denominator. So the least common denominator here would be x times x minus 5. So we're going to go ahead and multiply both sides of the equation by this least common denominator. Okay, on the left-hand side, if I multiply the x times x minus 5 by 1, we get x times x minus 5. When I multiply the x times x minus 5 by the 8 divided by x minus 5, these x minus 5s will cancel out, and you're just left with 8x. On the right-hand side, this x divided by x will cancel out, and we're just left with 3 times the quantity of x minus 5. So now you don't have any denominators to worry about, and you just go ahead and distribute, combine like terms, and solve the equation from here. So we end up with a quadratic of x squared minus 16x plus 15 equals 0. which we can factor into x minus 1 times x minus 15, and then we get our two solutions of 1 and 15. Now don't forget to go back and check by substituting x equals 1 into the original and x equals 15 into the original. And it turns out that both of these solutions are acceptable and valid. So 1 and 15 are both of our solutions here. All right, I think hopefully you're getting the hang of this. Let's try one more example for this lesson. I'm going to start by factoring our denominators, and you see we have x squared minus 9, which is a difference of squares. So you can factor that into the quantity of x minus 3 times x plus 3. So rewrite the equation with all of the denominators factored before you identify your least common denominator. And now you can easily identify that the least common denominator here is x minus 3 times x plus 3. So that's what I want to multiply both sides of the equation by. All right, so on the left, if I multiply by 6 over x minus 3, these x minus 3 quantities will cancel out, and we're just left with 6 times the quantity of x plus 3. On the right side of the equation, if we multiply first by 8x squared over x minus 3x plus 3, both of those quantities will cancel out, and you're just going to be left with 8x squared. And on the right side here, if I multiply by 4x over x plus 3, the x plus 3 over x plus 3 quantity will cancel, and you're just left with 4x times the quantity of x minus 3. So that was the hard part, getting rid of the denominators. Now you just have to distribute, combine like terms, and solve. And this equation ends up being a quadratic, which means we have to factor. Our factors here end up being 2x minus 3 and x plus 3. So we get x equals 3 over 2 and x equals negative 3 as possible solutions, but don't forget we have to go back and check that these solutions work. So I'm just rewriting the original equation, and I'm going to substitute 3/2 in for x and check to see that it is a true equation. And we do end up getting here that negative 4 is equal to negative 4, so that means that solution is good. And now in for my x, I have substituted in negative 3, and I'm going to go ahead and see what happens here. Notice negative 3 squared minus 9 is 0, and negative 3 plus 3 is 0. So on the right side of the equation, we have two undefined expressions here. Since these are undefined, there's no way that this makes a true equation, which means that x equals negative 3 cannot be an acceptable solution. So x equals 3/2 would be our only solution in this case. All right, guys, that's it for this lesson on solving rational equations. Thanks.